Let's do a problem from your lab assignment, section 11.9. We want to find a power series representation for the function and find the interval of convergence. Our function is 5 divided by 2 minus x. So again, similar to our geometric series 1 over 1 minus r, we want to make sure that we have a 1 in the numerator and a 1 as the constant term in the denominator, and then a negative sign. So we know that this is a series that is essentially r to the nth power. And then to make it look like that, we can take a 5 out from the numerator and take a 2 out from the denominator. If you take a 2 out from the denominator, you're going to be left with a 1 as a constant term, but then you also need to take a 2 out of the x. And if you do that, you're going to get x divided by 2. Now that we have that, we know that our series is going to be 5 halves times this, which we know is the r value raised to the nth power, where r is equal to x over 2. So we can put a 5 halves here, and then an x divided by 2, and we'll raise that to the nth power as our geometric series. Here's another representation of that. They have the 5 x to the nth power, and then we have 2 times 2 to the n, so that's 2 to the n plus 1. So we know that this thing has an interval, the geometric series has an interval of convergence from -1 to 1, which means the series converges for r, absolute value of r less than 1. So we're going to take the r value, which is x over 2, and then we're going to say that that absolute value of that should be less than 1. So when we solve for this, we take out the absolute value and have a -1 less than x over 2 less than +1. And then when we multiply 2 on both sides, we're going to get -2 on the left and a +2 on the right. So that's your interval of convergence, and that's the end of the problem.